Hi there, mathematicians. Let's take a look at lesson 4.5 regarding dilations. To start off, our essential question is, what does it mean to dilate a figure? So on the first page of your textbook, 211, we see two explorations in which you have an opportunity to use your dynamic geometry software, which is your graphing calculators, to draw triangles, label, and dilate. Use the dilate feature in the geometry mode of your calculator, and you can create these images and activate the dilate and get your coordinates for all the vertices of the triangles that you create, for the initial triangle that you create, so your pre-image, and then the one that you dilate, so the A prime, B prime, C prime. And the point of dilation for this exploration 1 is the origin, which is labeled D. So if you follow all of these steps using your graphing calculator, creating your pre-image and dilating to get your image, and then activating the features of finding lengths of segments and measures of your angles, you can compare the pre-image to the image and make some conjectures about what it means to dilate a figure. And then exploration 2 kind of talks you through similar steps of dilating lines in a coordinate plane. And so if you follow all of these steps and get the images and figure out the equations of the lines, you explore in a different way, dilating lines in a coordinate plane. So let's move on to page 212, where we see specific information about identifying and performing dilations, and then solving real-life problems involving scale factors and dilations. So some big ideas in this section are core concept in this box, and some highlighted words. So a dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point C, called the center of dilation. And we use a scale factor known as K, which is the ratio of the lengths of the corresponding sides of the image and the pre-image. A dilation with center of dilation C and scale factor K maps every point P in a figure to a point P prime so that the following are true. Okay, so we have 3 bulleted statements, in other words, properties of dilation. So the first property we see is if P is the center point C, then we can say that point P is equal to point P prime. And then second property is if point P is not the center point C, then the image point P prime lies on ray CP, and the scale factor K is a positive number such that K equals the ratio of C to P prime divided by C to P. Okay, so I've highlighted the C to P prime distance. So C to P prime is this yellow highlighted section. And so whatever this distance is, it's your top number of your ratio. And then the bottom number is the C to P distance. And that ratio is constant for every segment. So I could go from C to Q prime divided by C to Q, and that ratio will equal the same as this ratio. And I can do C to R prime divided by C to R equal also to this ratio. And then our third property is angle measures are preserved. So angle measures do not change when I dilate, only side lengths. Alright, so we see additional information here. Make sure you read through, especially paying attention to notations of information in this paragraph. We've got 2 new highlighted words, enlargement and reduction. Make sure you know what those mean in context of your scale factor. So specific values of scale factor will enlarge, so values greater than 0 will enlarge, and values between 0 and 1 will reduce. In other words, make smaller. So we have 2 examples where we're identifying dilations, and finding the scale factor. So our first example here, so look at this example from C to P prime divided by C to P. So 12 divided by 8, and we can see that in our solution here. So our scale factor, always reduce your fractions completely. So this fraction of 12/8 will simplify to 3/2. So the dilation is indeed an enlargement because 3/2 is greater than 1. And then our second example, part B, says C to P is 30 and C to P prime is 18. So when we identify the ratio of 18 divided by 30, our scale factor reduced is 3/5, which is less than 1, but greater than 0, therefore a reduction. Okay, then we have our dilations in the coordinate plane. And if P is located at XY, the preimage of a point, then its image, P prime, after a dilation centered at C with scale factor K is shown below. So your point center of dilation can be your origin 0, 0, which means every X value and Y value gets multiplied by the same K value to create your dilation. And then if the center is not at 0, 0, and it's some other point in the coordinate plane, which we'll call in general AB, so any other point in the coordinate plane, then it follows this special formula. This particular example is an example mapping of dilation with center at the origin. So here's an example number 2. Make sure you read through example number 2 for a dilation about the center. And then example 3 is a dilation not centered at 0, 0. So definitely make sure you read through both of these examples. So pause the video to capture both of these in your journal. And then a construction of dilation. So should be, make sure you bring in your dollar to buy your very own compass so you can practice all constructions on your own. So use a compass and straight edge to construct a dilation of triangle PQR with a scale factor of 2. Use a point C outside the triangle as the center of dilation. So here's your first step. So draw a triangle PQR and choose the center of the dilation C outside the triangle. So you draw rays from C through the vertices of the triangle. So when you sketch your triangle first, draw your triangle first, then choose the center by connecting where all 3 of these rays that pass through the vertex connect. And there's your center C. Alright, so moving on to step 2, we're going to use our compass to locate P prime on ray CP. So we want to figure out where this point's going to land so that the distance from C to P prime, so this full distance here, is equal to twice the distance from C to P. So from C to P, we want to double that to get to P prime. So locate Q prime and R prime using the same method. So you would line up your center of your compass here, measure the radius to P, and then double that distance. So you want to measure that using your compass, and then double that length so that you make a mark at P prime. And then measure your distance from C to Q, doubling it to create your mark at Q prime. Measure your distance from C to R so that you can double it and make your mark at R prime. And then step 3, connect the points P prime to Q prime to R prime and back to P prime, creating your dilated triangle P prime, Q prime, R prime. That is twice the size of the pre-image PQR. Alright, in the coordinate plane, you can have scale factors that are negative numbers. When this occurs, the figures rotate 180 degrees. So when K is greater than 0, a dilation with a scale factor of negative K is the same as the composition of a dilation with a scale factor of k, followed by a rotation of 180 degrees. We can see that with our picture here. Here's your pre-image, and then the scale factor negative k. Enlarge it with a scale factor of k, and then rotate it with a scale factor of negative k. And we can see the mathematical statement. Using our algebra and rules, we can come up with a rule that maps xy onto negative kx, negative ky. And here's an example to get into your notes and study and make sure you understand this example. All right, and then we have within the context of real life, real world problems, finding scale factors. Probably the best examples are photos that you can enlarge and have various sizes but not change the quality of the picture, but you are changing the size. So read through this real world example, noting scale factors, and then finding length of an image, also using scale factor, and then you can try 2 on your own. And then we see at the bottom of the page a horizontal stretch versus a vertical stretch. And when transformations such as dilations change the shape or size of a figure, the transformation is non-rigid. In addition to dilations, there are many possible non-rigid transformations. 2 examples are shown below. It is important to pay close attention to whether a non-rigid transformation preserves length and angle measures. And so we can see a horizontal stretch. Here's image ABC, triangle ABC. And then it's enlarged to be A prime, B prime, and then C. And then a vertical, and this affects the X value. And then the vertical stretch affects the Y values. And we can see that A prime stretched, but the horizontal did not, only the vertical. All right, and that's all for 4.5. So we'll make sure you know how to attempt some of these problems, and we'll practice some of these skills in class.